calculators. We need your calculators today. Here are some review problems.
For the math. I never had anybody because nobody in our friends like
All right, here are some review problems. Gibran, where you been?
Gibran.
Where'd you been? We are going to be on 317. This is still section 3.4. Everybody gets just one, please. I have a lot of football players. Okay. Now, these are review problems. Thank you, Jared. These are review problems. Okay, groupies? We have done these before, but it's been like 5 days, so let's get ourselves back in the swing of it. One option is to change this into its exponent form. Abby, paying attention? And say what? How would this translate?
4 to the x.
Perfect. 4 to the x equals 16. I don't know who said that, but you're an all-star. 4 to the x equals 16. Now, everybody knows 4 to what power is 16? 2. So that's the answer to the question. Easy, easy, easy. All right, what about this one? How does this one translate?
5 to the x.
5 to the x equals 1/25. Now, wait a minute. This one's not quite so easy. It's got a 1 over. What does 1 over always mean? Negative exponent. So this is 5 to the x, not 5 squared, 5 to the negative squared, right? 25 is 5 squared, but it's 1 over, so it's got to be a negative exponent. So what's the answer to this question? -2. Perfect. We've done these. These are review. What's this one say? The answer is 1. It says 6 to what power is 6? 6 to the x is 6. So this one is 1. Is your hand up, Maya? Here comes a tricky one. 4 to what power is 2? 1/2. How do we know that? Because isn't 2 the square root of 4? And what power is square root? 1/2. Remember, we've got to remember 2 things. 1 over means negative exponent, and radical means fractional exponent. So the answer here would be 4 to the 1/2. So x equals 1/2.
For the first couple, could you just make sure the instead of equal?
You could say log base 4 of 4 squared. Is that what you mean?
Yes.
Absolutely. Absolutely. You could actually do that with all of these. It's just a little bit tricky, some of them. Okay? Now, that is cool. But the reason this worked, you guys, is because there was a special relationship between all these pairs of numbers. Today's lesson is, what do we do when we don't have that special relationship? For example, what do we do if we have to find the log base 4 of 13? Well, that's going to be a problem, isn't it? Because 13 can't be, 4 can't be turned into 13. Like 4 can be turned into 16, but it can't be turned into 13. So we're going to set this equal to x, just like we did those over there, and we're going to translate it. So Thomas Burke, what is this going to say when I translate it? Get rid of the log. Make it an exponent now. So it's going to be 4 Look over here, Thomas. This became, this one right here, this problem became this. This became 4 to the x equals 16. So 4 to the x equals 13. Step 1. Tim Kelly, I need your eyeballs focused up here. Step 1. 4 to the x equals 13. Got it? Now, I'm going to take the logarithm of both sides. Now, you might be thinking to yourself, Ms. Ford, why are you doing that? But I'm getting ready to show you. What happens, we talked about this on Friday, what happens when you take the logarithm of something to a power? What happens to that power? Where does he go? Out here. Remember that? Exponents become coefficients in logarithm land. So when I take the logarithm of both sides, all of a sudden this guy comes out in front. And if I want to know what x is, all I have to do now is divide. So x ends up equaling the log of 13 divided by the log of 4. And I get my calculator out, and I type log 13 divided by log 4. And the answer is 1.8502. Now, a little word of caution, if you're using, I don't know what your particular calculator does that you're using, but when I type this in, as soon as I press log, my calculator automatically puts a parentheses. You must close that parentheses before you hit divided by log 4. Make sure that you close your parentheses. Taylor Holder, I'm not sure what you're talking about, but it cannot be as important as this. Okay. Did everybody come up with 1.8502? Okay, Katie, where's your calculator, honey?
Oh,
Yep, let's get it out. Now, let's get our note sheets out, and let's look at a few problems in the note sheets. We are on the back of 27. We are looking at number 3. We just took a few notes. We're ready to rock and roll. Here we go. Log base 3 of 4. Log base 7 of 11. And log base 0.4 of 12. I will start with these. Here we go. This is A, part 3, backside of 27 in your note sheets. Everybody there? Step 1. Think of this problem right here. Step 1, what did we do first? Let's set it equal to x and then translate it. What does it translate into? One step at a time. 3 to the x equals 4. Everybody okay with that? Now we're going to take the logarithm of both sides. And why do we do that? So that what happens to this guy? Where does he go? Out in front. So x log 3 equals log 4. And then what will x end up equaling then? We're going to divide, right? So it'll be the log of 4 divided by the log of 3. Let's type that in and see what we get. Don't forget, if your calculator puts those parentheses in, don't forget to close them. I got 1.2619. What did you get?
Yep, same thing.
Okay, here we go. Step 1, I said equal to x. What's step 1?
Rewrite it.
Rewrite it, and it'll rewrite as 7 to the x equals 11. Now, if this were a 49, I'd be all set, right? But it's not. So now at this point, I have to take the logarithm of both sides. And the reason that I do that is so now I can do this magical, mystical step, which is what?
7x.
The x comes out in front. That's one of our properties of logarithms that we talked about last week. So my answer will end up being the log of 11 divided by the log of 7, which is 1.2323. Olivia, you paying attention, dear?
Yes.
Good girl. Now, this one's got a decimal in there, but you know what? That's going to make no difference whatsoever. We're going to do this problem exactly the same way. Jack?
Do you care if we list our steps or like?